Okay, so similar volumes. This is just, you know, same sort of idea, but things are increasing by volume rather than just by length or by area. So the only difference here is that when you are increasing something by volume, you're not increasing it in one dimension, the length. You're not increasing it by 2 dimensions, the area. You're increasing it by 3 dimensions, length, breadth, height. Okay, so the only difference here is we take our length scale factor, and to form our volume scale factor, we just cube that fraction. So the area scale factor, we squared it. The volume scale factor, we cubed it. I think that's fairly easy to remember. You know, we associate area with kind of squared, and we associate volume with cubed. So make sure that you have what's in this grey box written down just now, please. So to get the volume scale factor, I actually would offer you an alternative. You don't need to write what's in. I would swap that for the length scale factor cubed. We know how to find the length scale factor by now, okay? I hope. So it's basically the length scale factor cubed is all you need to know. Okay, so that's how you get your volume scale factor, then you just times it by the old volume. Okay, so I think that, you know, if you're fine with area, then this should be fine as well. So example 5 is what we have to do just now. So I do want you to draw a couple of coffee cups for me, just the outline of it. Just draw me 2 cylinders essentially. Doesn't need to be a work of art. So coffee is sold in cups which are mathematically similar. A large cup has a base 10 centimeters wide and it holds a volume of 625 milliliters. I'm going to write that underneath my diagram. V equals 625 milliliters. Okay, a medium cup has a base 8 centimeters wide. What is the volume of it? Okay, we don't know what the volume is. Question mark. Right, so this is basically the exact same process as finding the area scale, a kind of new area. We're going to get the length scale factor first. So draw me the coffee cups, write on the information. We're going to get the length scale factor first. Just going to pause this for 1 second, hold on. So you should be drawing out these coffee cups, put on information, and now here's our 3 steps that you can maybe write down. So find the length scale factor first, then find the volume scale factor, and then find your new volume. It's pretty straightforward. Okay, so the length scale factor again is by comparing the corresponding lengths. So we need the new length, which is the one with the unknown in it. That's going to be the smaller one, divided by the old length. So the new length is 8 divided by the old length 10. So what you need to make sure is if you're asked specifically for the length scale factor, you need to make sure your fraction is in its simplest form. They're both in the 2 times table, so they can be divided by 2. So it becomes 4/5. Okay, the volume scale factor is 4/5 cubed. Okay, now actually at this point we don't actually need to work out what 4/5 cubed is. Now I know we've done that previously, but with the area scale factor we did the top squared over the, we actually don't even need to do that. As long as we are comfortable putting in that fraction cubed into our calculators, we don't have to work it out. Okay, so it's probably going to be easier for the area and also the volume to just say that the new volume is going to be 4/5 cubed multiplied by the old volume, so times by 625. So if you're able to put that into your calculator carefully, then do that. If you're not able to put it into your calculator, then you're going to need to do 4 cubed over 5 cubed, which is going to be 64 over 125. So you put that fraction in times by 625. But if you can put that with a bracket in, then that's probably going to make your life easier. If you don't have a calculator at home, you might find it difficult to put in 4/5 cubed into like your phone or into laptop or something. So you may have to work out what 4 cubed and 5 cubed are and put in the fraction. Write your answer in the comments, please. Let's see it. What did you get? Right, good stuff. All getting the same answer. It is 320. That's correct. Well done. Yeah. 320, and remember, we need the units here for volume. In this case, it is millilitres, which is, remember, millilitres is the same as centimetres cubed. Okay, well done to all of you. Thank you for giving me that answer. Good job. Okay, so find the length scale factor, cube it, times it by the old volume. Pretty easy, I think. We're going to look at example 6, which is very slightly different. Okay, so apologies. Right, example 6 now. A shampoo manufacturer prices its bottles according to their volume. Okay, so sometimes it won't, in these questions, they might ask not in terms of what is the new volume, they might ask you what is the price, and the price is related to the volume or related to the area. Okay, so to sell a regular size bottle, it has a height of 14 centimetres and a cost of £3.20. The super size bottle has a height of 28 centimetres. What is the cost of it? Okay, we don't have a diagram here. Now, I don't like working without diagrams when things involve shape, so that is our first thing that we're going to do. We're going to draw a couple of shampoo bottles here. Okay, so draw me a couple of bottles, please. Like that. That'll be one of them. Okay, so we've got a small bottle first, which is 14 centimetres in height. And the cost is £3.20. And then we've got our super size bottle. You can see I'm very skilled in the art of drawing. 28 centimetres is the height. What is the cost? Okay, now the mistake that people make is they rush into this and they look at the difference between 14 and 28 and they think, well, that's just doubled, so the cost will just be doubled. No, because remember, when we figure out that length scale factor, we're not just doubling it, we then have to do that to the power of 3. We have to increase it in 3 dimensions. So don't just jump in and try and be clever and think that that's how you do it, because it's not. Okay, the first thing we're going to do is find me that length scale factor. We're going to stick to the process. Okay, it is new over old. So that's going to be 28 over 14, which divides into 2 whole numbers. Now this is volume we're talking about. So the volume scale factor, we now have to cube that. So it's 2 cubed. Now this is easy enough to work out. 2 cubed is 2 times 2 times 2. That's a value of 8. Okay, so to get the new volume, or the new cost, sorry, we take our volume scale factor and multiply by the old cost. So the volume scale factor is 8, it's 2 cubed, times by the old cost, which is £3.20. Work that out, write your pound sign, and then that's it. I mean, this is actually easier than the last one, so I won't get you to tell me the solution because it's straightforward enough. 8 times 320, £25 and 60 pence. So 25.6. Remember, we're talking about money, so 25.6 has to be written as 25.60. And that is my new cost. Or you might want to say super size cost. All right, so if you've got on fine, with the area yesterday, I think you'll be fine with this today. The exercise we're doing is the next one in Unit 4, which is just basically similar questions to area, but really in the context of volume. Okay, then what we're going to do tomorrow morning is we are going to look at a kind of mixture of questions and more kind of exam style past paper questions. Okay, but I think we'll be all right with this. I'm pretty confident. I'm getting some good vibes off you so far with this topic. So let's hope that continues.